Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Want to write cleaner Flutter code? This talk by Ivanna Kacevica, software engineer at World of Mouth, will give you valuable tips on how to best use the new features in Dart 3. Let's go!
Hi, it's Ivanna from World of Mouth Restaurant Guide app, and today I'm going to be talking about biggest Dart 3 features such as records, patterns, exhaustiveness checking, and sealed classes. And I will do it by showing you examples of code before and after it was refactored using Dart 3. Now let's start with an example. Imagine you are working for a social media platform and you have your teammates' code to review. The code will be related to this post comment button UI. I will show you a code snippet on the next slide, and I want you to think about these questions. Number 1, is the code easy to review? And number 2, is the code easy to maintain? Now remember, the questions are, is this easy to review? And is this easy to maintain? So how do you feel? Is it readable? Well, personally, I'd say this way of coding isn't really easy to maintain. Also, it would be quite hard to test this logic completely. So let me show how the same code would look if your teammate would use Dart 3 features instead. I will give you a couple seconds to get familiar with this new syntax. So how about this refactored code? Does this look cleaner to you? And how about maintaining this? Now, when we have seen one example of code cleanup using Dart 3, let's rewind a bit and start with some basics. For the context of this talk, our hypothetical app is this simple social media app like the example shown here. It has image posts and users can like and comment on those posts. And we have two custom classes in our app, which are post and user. We will start with some JSON, validate the JSON, convert it into a typed object, and then use Flutter to display data from that object. First, we will take a look at a couple examples of using pattern matching specifically to validate some JSON. So this is the data map we will start out with. The data represents a post on our social media app. This app supports image type posts, and it also contains data related to the user who posted the image. Let's explore how we can validate that the data from our backend does not have any errors. Before Dart 3, this was how you could validate your map. You need to check each property you are expecting, ensure that the key is present, the value isn't empty, and it's the correct type. For example, here, first we check if the likes key exists. Then we verify that the value for likes is not empty and is a number. Next, I will show you how we could refactor this code using Dart 3. So this is how you would implement the same validation with patterns. The highlighted part represents the actual pattern or the shape of a value that you want to compare with an actual value. For example, this single line checks that the likes property exists in the map and that its value is an int and not null. It also uses the underscore syntax known as a wildcard to indicate that we don't care about the specific value here. It could be any int. Remember, this is how that line looked without pattern matching. So we have refactored it quite a lot, right? And that's not all pattern matching can do. Imagine our requirements have changed. Now our project manager said that we have image posts, but also text posts, which extend the base post class now. The incoming data now looks like this. It includes two different object types. They are quite similar, but the second object represents a post of the type text. Instead of an image path, it has a post body property. We will need to tweak our pattern matching to support both types now. And if we were to expand our previous example, we would need to add something like this, which starts to become quite unreadable at this point. So let's see how we can handle this with patterns. With this switch expression, we are matching against two different patterns. In the first case, you see that we have type text and a non-null string post body. And in the second case, we have type image and a non-null string image path. In our example, this approach is really useful because we deal with two different subtypes of one post class, text post and image post. And our goal is to return the subtype that aligns with the type property in the data. We will continue with the same example and explore even more tips and tricks for patterns, starting with destructuring. Let's revisit our example here. In it, we are using wildcards or underscores to match the values in the pattern. So just as a reminder, in the case of the likes property, we are essentially saying there must be a property named likes, and its value must be an int. But the specific int value isn't important to us. This is very useful, but it's not the only way to handle values in a pattern. We can also destructure the pattern if we want to utilize the values we are matching against. To illustrate this, let's update our method. Instead of validating the JSON in one method and then calling from JSON separately, let's combine validation and object creation into a single method. In this version of a method, I am still matching the pattern against the JSON object, but then I am directly returning a text post object without calling from JSON because we are within the from JSON method itself. So instead of using wildcards, we can assign variable names to the values. If the pattern matches, Dart will automatically create variables and assign to them the corresponding values from the object that you are matching against. These variables can then be directly passed to the text post constructor. And this process is known as destructuring. In our case, Dart takes a JSON object and extracts individual values, assigning them to separate variables. That's all the refactoring we will do on the JSON validation today. So now let's shift our focus to the Flutter widget code. Here we are creating a post object using the previous from JSON method and then passing it to either a text post widget or an image post widget based on the post type. However, with Dart 3's features, we can enhance this process even further. Let's take a look at how we can improve this. So far, we have refactored our JSON validation to use patterns, making the code less verbose and more readable. But the data we are working with is relatively simple. So what if it wasn't as simple? Imagine a project manager comes to you and says, hey, let's add video posts to our feed. Not only that, but let's also introduce the option for users to pay for extra features. So we need to add another user type. And just to cover all bases, we also need admin user because obviously all apps need admin users. With these changes, our class hierarchy gets more complex and so does our incoming data. Actually, our JSON doesn't change much. The most notable addition is a type field in the incoming user data. The validation part of the code remains largely unchanged. We will simply validate that our user is a map and destructure it into a user variable. This variable will be used in user from JSON, which is our new method that needs to be implemented, much like the previous one. So let's revisit this Flutter code. With the introduction of additional post types and user types, we will need to create extra widgets to display these various subtypes. Now, in our example, we will end up with 2 additional if statements to return the correct widgets. And this code isn't too bad, it's still quite readable thanks to collection if statements, but it does introduce some issues. First off, we seem to have overlooked admin users. While we could add a line for admin user, it doesn't protect us against the future addition of more post types or more user types to the app. Also, what if the post and user objects don't match any of the cases? Then what, end user would just see a blank screen? Fortunately, Dart 3 offers a solution with its exhaustiveness checking feature. Exhaustiveness checking means that you would get an error during the coding stage if value could go through a switch statement but didn't match any cases. Take this switch statement as an example. Dart knows that true and false are the only options for a Boolean like is true. So no need for a default case here because we already switched over all the cases. This kind of checking has always been there for enums as well. If you look at the enum here, if you miss a case for a fish or don't have a default case for any other possibilities, you will get a warning. And with Dart 3, we can also apply this to our custom classes. To use exhaustiveness checking on our custom classes, we need to use new sealed class modifier instead of abstract. The word sealed here means that all the possible post types are now text, image, video, and nothing else. And all the possible user types are normal, admin, and paid. So when we refactor our code like this, Dart becomes completely certain that every possible subtype of post is in the same library. As a result, it can accurately inform you if you have missed a type. In fact, the code won't even compile if you missed a type. And since we are sure that no types are missing, we don't need a default case in our code. So if I were to comment out the last case in the code, Dart would throw an error that I am missing a case. So if I go back and add a new subtype, for example, GIF post, our code won't compile until we include a case for GIF post in this method. And this ensures that every possibility is accounted for. Of course, in this example, we would need to add a second switch expression to obtain the appropriate outer widget. So we could use both of these expressions and place their outputs into a column to display the result. But there is actually a more efficient way to do this using destructuring. We can refactor the 2 methods responsible for retrieving the widgets to look like this. We have 3 post types and 3 user types, which means there are 9 total cases to match against. Just as you would expect, the pattern matching system in Dart is smart enough to make sure we've covered every combination of values in our code. So with 3 sealed user types and 3 sealed post types, Dart will expect us to switch over all 9 possible combinations of those. And of course, if I remove one part, even if I have implemented the other 6 cases below, the analyzer will still flag an error. And this happens because it anticipates that we must handle every possible scenario, including a case for a text post with a paid user. Sticking with the same example, let's also explore a final part, which is a Dart feature known as records. Notice here how we are returning not 1, but 2 widgets from this method. This is an example of using a record, which is a feature enabled by Dart 3 as well. Records are this new kind of collection that can contain any number of elements, and most importantly, these elements can be of different types. Records are useful for handling multiple values that are logically connected, especially when creating a class with these values would be too verbose and unnecessary. And using a list isn't ideal as well, because with list you would lose the specific types of the values. So imagine the build method of your widget looking like this. In this scenario, we are calling the getPostWidgets function, which will return a record. And then we are destructuring the record into 2 separate variables using the record syntax. This means we are pulling these 2 variables out of the record right here. Before Dart 3, we would likely return something like a column, not a record, from this method, and we would include both elements in that column. However, that approach could present some problems. What if your build method was set up like this? You would have some title widget, and then the post and outer widgets would still be dynamic. This setup would result in having a column within a column, which could add unnecessary overhead to your application. And of course, there are other ways to return multiple widgets, but using records makes things much simpler. There is no need for complicated methods or extra code. This approach instantly makes our work easier. For example, we could easily add our title widget right in this part. That's it for today's session. Today we quickly covered the biggest Dart 3 features. If you want to learn more about Dart 3, check out the Code Lab at the QR code right here. And if you need great restaurant recommendations around the world, make sure to check out World of Mouse. It's absolutely free. So thank you for being here today, and I hope you will start using Dart 3 features after this session.